In example 2, we need to sketch the parent function for the cubic function. The parent function for the cubic function is going to look kind of like this. Some people describe that as sort of S-shaped a little bit. It also has this little point right here we call a point of inflection, so it's where the graph kind of changes around there. And if you were to choose that point, the graph would have point symmetry around that point. In other words, if you rotated it 180 degrees on that point, then the graph would look like itself. Anyway, we'll do f of x here, and the parent function is just the simplest form of the cubic, and x to the third, hopefully you guessed that one, is what we need. Notice there's no number here, no other numbers doing anything. This is just the simplest form. That's the parent function, the simplest form of this. We can make a table of values. And again, the goal is to get you to memorize these values and to be able to come up with them quickly. So we've got -2, -1, 0, 1, and 2. And at a deeper level, to understand why this graph doesn't look like a graph that's x squared or even just x. This 3 changes things for us. It's going to change the outputs for each one of these inputs. So let's see what the output is. That's this column. When the input is -2, and this should just be, sorry about that, that should just be x there. So what we're going to do now is we're going to plug that into the, or substitute into the equation. And we've got -2 times -2, which is 4, times -2, which is -8. We've got f at -1 here. That's going to be a negative times a negative times a negative. 1 times 1 times 1 would be -1. F at 0 is an easy one. That's 0 to the third power, which is 0. F at 1 is 1 to the third, and that's +1. So this time, unlike the quadratic, y is equal to x squared, the values here are negative and the values here are positive. We've got 1 we said, and then 2 times 2 times 2 is going to be 8. I'm going to move this up just a touch. We will need to see the bottom of this graph. And we'll plot these points. So we've got -2, -8, 1, 2, 3, 4, 5, 6, 7, and then 8 would probably be down here. Not a great idea to go pretty far off the graph, but this is only 1 unit down here. And so to get our shape, that's okay. The next one is -1, -1, 0, 0, 1, 1, and 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Right there. We know it's going to have this kind of shape, and so we'll try to do that as best we can. Make sure we have a nice curve here at this section. We want it to be kind of like a pinwheel, you know, where it has the same shape but just rotated 180 degrees. By the way, if you were paying attention to the last learning target, the graph f of x is equal to x cubed has point symmetry around the origin. And this point where the symmetry exists is called the point of inflection. And it's also odd. It's also odd. Whenever a function has symmetry about the origin, we call it odd.